That seems to be being lost in the shuffle with my classes is you guys don't seem to be aware that all four forms of an equation are the same thing. So some people may have chosen to do these with slope-intercept form or with general form, and that's okay if the answers are still right. I, of course, use the form that uses the information that I have been given. And since in this very first question, I was given a slope and a point, of course, I would use point-slope form. And point-slope form is right there. Slope goes in front, and these are, of course, the opposite of the points you see there. There are the first four. They're worth one each because you only had to know how to substitute into a formula. Any questions about A through D? C is tricky because I gave you an x-intercept. And some people in the other class threw that right into slope-intercept form without recognizing that it was an x-intercept I gave you, which is technically a point, so you can use 3, 0. Jacob.
So you didn't write y like minus 0 because it's like unnecessary, but it's still not wrong.
No, of course not. Okay. Excellent. A lot of people have trouble with these when I give the x and the y-intercept and recognizing that that is, of course, a negative slope. Both of these are positive numbers, so of course people are always like, oh, then it must be a positive slope. Of course it is not, because as soon as you think about it, you recognize that it has to be a negative slope. So you needed a negative there. Those are the problems other classes had with this. Do any of you wish to ask about anything else, or did I cover your questions already? Excellent. There are the next four. There, 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 and there. The problem that most of my students had with these four was G. They were not very happy with the fraction there. But of course that is okay, because that point indeed exists upon the graph. They just didn't like writing it there because they didn't want to have to graph it there. But it is okay. Any questions for E through H? Lovely. That page is out of 8. So this is, I think, the easiest version of the final answer. But of course you may have something else. The hints to solving it, of course, as always, come from the question. The lines are perpendicular. So you know line 1 has a slope, and line 2 has that same m, but it's reversed, reciprocated, and had the sign change. So once you found the slope, which I did by taking the equation I knew, putting it into slope-intercept form, which gave me the slope I needed, I realized that I had to reciprocate it and change the sign. That got me the slope I needed. How did I know the y-intercept was 8? Well, it was right there. How did I know the y-intercept here was 8? Because the question tells me the lines cross at the y-axis. A line can only hit the y-axis once. So if the first line hits the y-axis at 8, the second line must also hit the y-axis at 8. Gouda? Great. As you can plainly see, that is out of 2. This question was a little more difficult. It's still perpendicular, so I'm still flipping the slopes. But I don't have an intercept, I have a point. One of the lines was right here. That, and I will highlight that in orange, got me my slope. Once I had my slope, I knew I needed to flip it and change the sign. That got me my new slope. And I knew I went through that point. So since I had a slope and a point, I could put it in point-slope form. Remembering that point-slope form is y minus y1. So when I put that y1 in here, I get y minus minus 4, which is, of course, y plus 4, also out of 2. Any questions for number 3? Well, I scratch my leg because it's a little itchy. Sometimes it happens. Damn it. Luda? Great! This is what your line should look like, or your graph should look like, something like this. 2 lines with the same slope and 1 line cutting through at 90 degrees. 1 mark for graphing each of them. Give yourself a total on that page out of 7. Page 234 has 3 multiple choice questions. Barring anybody needing to know why, the answers are D, D, C. Does anybody want to see the work for any of them? It's all on the screen. Just tell me which one you want. I'll just stop there. Whew. 5. So, I'll shrink it down so all the choices are on the screen. Just take care of that first. Now, this tells me I have to go through positive 6. So that one's wrong. That one goes through positive 6. That one goes through positive 6. And that one goes through positive 6. It also tells me I need a negative slope. So it can't possibly be that, It can't possibly be that one because that's a positive slope. Then I just check my slope. The slope was negative 3/4. Down 1, 2, 3, left 1, 2, 3, 4. That line doesn't go through that dot, so it couldn't be him. Had to be him. Anything else from 234? 7. Indeed I can. So on 7, I knew I had a point. And if I have a point, then I should probably go to point-slope form. But I didn't have a slope. But I did have a slope because I had 2 numbers there. So, negative 2 minus 0 is negative 2. 9 minus 1 is 8. The slope I had was negative 1/4, and there was my point. So I put it into point-slope form right there. Right? But you can see I didn't have point-slope form over here, so I had to convert this to slope-intercept. I brought the 10 over, and it became plus 10. I distributed the 1/4, negative 1/4 x, and negative 1/4 times negative 8 is positive 2. Then I added 10 and 2 because they're like terms, and I got negative 1/4 x plus 12, which was the answer. Algebra is your friend. But it's a little high maintenance friend, right? Right? It's the friend that's always asking you for crap, and you're like, damn, man, do it yourself. But they never do. And then that screws up your life, so you might as well just help them. Now, number 8, I don't know where the choices went. So you're going to get 2 marks here because it wasn't multiple choice. Of course, you graphed it, or you didn't graph it. You used the graph to get your slope, which was 4/5. And then you needed a line through there that was perpendicular to this line. So, oh man, I forgot to perpendicular it. Didn't I? Oh no, I did. 4/5 was the slope. 5/4 was the slope that you had, so I changed it to 4/5. Because this slope was negative 5/4, so I made it positive 4/5. Then I cross-multiplied to get k equals 26. And that gets you 2 points. It should have only been 1, but the choices disappeared. And the last question, when graphed, what is that slope? Well, if I put it in slope-intercept form, I get it. The mistake you guys all make is you think that 10 has anything to do with the slope. Does it? No. It's the y-intercept once you change things around. It has nothing to do with the slope. And that makes the whole thing out of 3, and 3 is 6, and 7 is 13, and 8 is 21. And I'll get that from you at a later date. And we are moving on to page 244. But first, 242, 43. I know half of you Googled the joke because I said it would be funny. He was hoping for world peas. World peace, world peas, blended veggies. I love that one. You guys apparently didn't, but that's fine. So, we've now seen how to solve systems with graphing, and we learned that that sucks if there are fractions or decimals involved. So then I showed you substitution, which gets you a nice exact answer, but sometimes is also a pain in the butt, especially if there are fractions involved. Right? That last example I gave where we tried to do this one, and then we were all like, barf, I would have had fractions. And then I showed you this fancy move where 4x equals 4x. That was the lead into what we're doing today. So, today requires some explanation as to why it works. It's very easy to do, but I like you to see why. So, of course, we will begin, as we always begin, doing the easiest of the ways to solve a system. Graphing. Not the best, but the easiest. So the blue line, 3y equals negative 4x. Y equals negative 4/3 x. And then we just come over here and we graph it. Nope, I don't want to do it that way. Don't want to do it that way. Thank you very much. I would like a different color for my graph. For my graph. While my computer is frozen, you guys could be working on the other one. While my computer is frozen, you guys could be working on the other one. As usual, close, open. Negative 3y equals negative 5x plus 27. Y equals negative, not negative anymore, 5/3 x plus 9. Minus 9. And then, of course, you would graph them. And once you graph them, you will see that, of course, they cross, and we get a solution. The blue line is 1, 2, 3, 4, 1, 2, 3. And you will get Almost made it. And the red line is 1, 2, 3, 4, 5, 8, 9, and up 1, 2, 3, 4, 5. And you would go right through there, which was a solution, therefore, of 3, negative 4. Yeah? Easy peasy. Everyone is good? Okay, now listen to me, please, because I would like for you to do something. Pick a number between 2 and 9. Don't say it out loud. Just pick it and write it down. You have your number. Take that number and multiply it by the second equation, which is 5x minus 3y equals 27. Once you have multiplied that, solve for y. All right? So everybody has the number, their number that they're going to use, any number between 2 and 9. Go. And when you are done all that, you should notice something. What do you notice? It's the exact same thing. The new equation that you got, which was for me, since I used the number 4, was that, is actually the exact same as the original equation, right? Something that you have been seeing since about the 4th grade, when Mrs. Bad Crumble explained that 1/3 is the same as 3/9, right? Because I multiplied that by 3 and I multiplied that by 3. Not a new concept, something that you all know deep down in the very essence of your math core, right? So what does that tell us, though? Multiplying both sides of a linear equation results in a new, and put the new in quotation marks, a new equation with the same solution. So what's the only thing that changed? The looks. The looks is what changed, but the answers will be the same. Everybody cool with that concept? I can change the way my equations look, but it will not change the way they function. Everybody good? Spectacular. Turn the page over. Add those equations. So I'm going to add, and add. What is 4x's plus 5x's? 9x's. What is 3 plus negative 3? 0 y's. So do I need to write it? No. What is 0 plus 27? 27. So x equals what? 3. Now, if I were to graph this on the new equation on the graph up here, you don't even need to do this if you don't want to. It would be a line that would go right here, correct? Notice it goes right through my solution. But that line has an x coordinate, doesn't it? So, what happened when I added these together? Use your eyes. What happened when I added them? The y term was eliminated. Why is that a good thing? You get the x right away. Immediately. Right? This is half the class, half the years say this is the easier way. Now, what would happen were I to subtract them? What is 4 minus 5? Negative x. What is 3 minus 3? Positive 6y. And 0 minus 27? Negative 27. Now, if I were to graph that, I would find that y equaled 1/6 x minus 4.5. Now, if I were to go put that on my graph, and again, you don't have to do it, you can just watch me. Negative 1, 2, 3, 4.5 right there, correct? Slope of 1/6, up 1, out 1, 2, 3, 4, 5, 6. Where did that line go? Right through the same solution again. So what does that tell us? Adding or subtracting linear relations results in what? New equations that either have the same solution or eliminate a variable. Everybody cool? So now, knowing everything you know, I want all of you to write one more equation right there that would work towards solving that. There are an infinite number of answers. I'd like to see if everybody can find one of them. When you feel you have one, take a chance and volunteer it. The worst that can happen is I say that's not right. Anybody got one for me? Anybody? Looking for anybody out of 30 to be able to do one of the three things you just all sat there and said, yeah, I get it when I asked. Anybody? Hayden, hit me. 2x plus y equals 17. What did you do to get that answer? I'm not saying if it's right or wrong. What did you do? You subtracted, right? 3x minus 1x is 2x. 2y minus y. What should it be? It should be 3y. But, otherwise, acts very well done. You realized that you could have subtracted them. You made a little error that everybody makes, won't make it again. Anybody got another one for me? Jovan, hit me. 4x plus y equals 19. Absolutely right. He just added them. Anybody get another one for me? Hayden. Y equals negative x plus 17. How'd you get that one? 3y. Right. Okay. What else could we have done? I'm not going to write them out because now we're at the infinite spot, right? What else could we have done? Yep. What else could we have done? Multiplied either of these by any other number. Everybody cool? All right. So, turn the page over and we see, just like with substitution, I give you the steps you need to do. Step 1, add or subtract to get rid of one variable. So which of these am I going to try and get rid of, x or y? Y. And am I going to be adding or subtracting? Adding. What is 3x's plus 4x's? 7x's. What is negative 5 plus 5? 0. What is negative 9 plus 23? 14. Step 2, solve for the remaining variable. How do I do that? Divide by 7. Divide by 7. X equals 2. And finally, plug that value in to find the other variable. Where can this 2 go? Any x that I see anywhere in that question. Doesn't do me any good to put it here, though, does it? Because what am I trying to find now? Trying to find the value of y. So putting it there is no good. But could I put it there? Sure. Then I would have 3 times what? 2 minus 5y would equal negative 9. 6 minus 5y would equal negative 9. Negative 5y would equal negative 15. And y would equal 3. What if, like a crazy person, I decide to put it in that equation? What would I get? Well, I'd have 4 times 2 plus 5y equals 23. 8 plus 5y equals 23. 5y equals 15. And y equals 3. Would it have mattered where I put it? No, of course not. Mr. Myers, did I do this right? Did I do this right? Kid, did you do this right? Did you do this right? I don't know. Of course you know, because you know your answer is supposed to be 2, 3. What letter does that 2 represent? X. What's letter that 3 represent? Y. Is 6 minus 15 negative 9. Last I checked, is 8 plus 15, 23. Last I checked. So, kid, you did it right. You did it right. Got it? What's wrong with this one? Can't eliminate anything. But fortunately, Mr. Myers has given me a tool that allows me to change the appearance of these equations, but keep the same answer. What is that? Multiplication. What could I multiply this guy by to be able to eliminate something? If I multiplied him by 2, what would I get? 2x minus 4y equals 14. That would allow me to eliminate the y's, wouldn't it? What if I multiplied this guy by -3? What would I get? -3x plus 6y equaled -21, which would allow me, if I wanted to get rid of the x's, I could. Is there a right or a wrong way? No. So, we're going to stick, you do whichever way you want, but don't start yet, because what would I have to do over here? Same thing, I got to multiply by something. What should I be shooting for? Something bigger than the coefficients I have now, yes? Well, what would work? Jacob? Yes. If I multiplied that by 11 and I multiplied that by -2, could I eliminate the x's? Absolutely. Is there another thing I could do? What if I multiplied this by 2 and this by 3? What would I eliminate then? The y's. Does it matter? Does it matter? No. But there's a warning here. And I'm going to show you on the side. It traps you guys every so often. 3x plus 2y equals 13. And plus in this one, can you eliminate something right away? Jacob? You could. You could also subtract. Everybody with me? Well, if you add, nothing's going to eliminate. But if you multiply by -1 and add, you're going to get -3x minus 5y equals -19. Then you can add. Now, you want to be careful if you have something like this, if it looks like this. Oops, damn it. What did I have? I had 3x equals 13. If my other one looked like this, if I wasn't going to multiply and I just wanted to subtract because I saw those were exactly the same, then what would the answer be? This would disappear. What would be written here? 7y. Because it's 2 minus 5. Does everybody understand that? You have to be careful if you're going to subtract. Or you do the trick I taught you yesterday, where you make 3x equal 13 minus 2y, and 3x equal 5y minus 3, and then you make them equal. Everybody cool? All right. Try it. Solve these two, then you can check your answer with me, then you can get to work on whatever it is you see fit. Of course, this way is easier.
Which way do you fight?
I use elimination almost all the time. Almost always. But sometimes substitution is easier to deal with. It depends on the question. If you already have an isolated variable, why wouldn't you just use substitution? everybody should be good. Now, once again, as always, I have given you some practice work with the answers. If you're not 100% comfortable, do some of this so you can check it over. If you feel you're 100% comfortable, I got another puzzle sheet. This one's funny too. You do as much practice as you need to be able to solve systems with elimination. I cannot know if you have done enough work until I mark it. You must know if you have done enough work to do this. Okay? But the nice thing about this unit is, do you ever need to be unsure of your answer? No, because you can always check it. And if it doesn't work, you screwed up somewhere in the algebra. And if I were you, I would bet my money on it being a wrong negative somewhere. Like forgetting when you divide a negative by a negative, you get a positive. Or forgetting when you move something over the equal sign, it switches signs. Okay? Okay.